For countless ages, human beings have gazed into the endless darkness of the night sky, filled with awe and wonder about the many unexplained secrets that lie beyond our world. In the 1900s, scientists introduced a theory known as the Big Bang to describe how the universe came into being, how it developed, and why it continues to grow. Although this theory gained widespread support, it still fails to provide answers to some of the most basic questions about the cosmos. In recent times, groundbreaking discoveries have made these mysteries even harder to unravel. One such moment came in 2023 when NASA's James Webb Space Telescope detected astronomical objects that appear to be older than the universe itself. This revelation stunned scientists and ignited a heated debate. Could it really be possible for stars to exist longer than the very universe they reside in? Webb's discovery has challenged the current understanding of space and time, raising the possibility that our entire model of the cosmos may need a fundamental overhaul. These types of perplexing are exactly what we'll be digging into. If you're fascinated by the cosmos and want to stay in the loop with new discoveries, be sure to subscribe, hit the like button, and turn on the notification bell so you never miss a moment. Roughly 200 light-years away from Earth, in a constellation known as Ophiuchus, lies a particularly intriguing star called HD 140283. What makes this star so captivating isn't just its speed, traveling at a blistering 4,483 kilometers per second, but the story hidden in its past. Around 1 billion years ago, during the early formation of the Milky Way, our galaxy collided with a much smaller one, and this star was among the survivors of that cosmic crash. Yet what truly sets HD 140283 apart isn't its journey or speed, it's its age. Nicknamed Methuselah, after the legendary biblical figure said to have lived nearly 1,000 years, this star is considered one of the oldest ever observed. Initial calculations put its age at an astonishing 16 billion years. More recent estimates have refined this to about 14.46 billion years, with an uncertainty of 800 million years. This still places it older than the estimated 13.8 billion year age of the universe, as calculated using data for the cosmic microwave background radiation. This apparent inconsistency has forced scientists to reevaluate how we measure the ages of stars and the cosmos, driving deeper inquiry into these confounding astronomical riddles. To fully grasp this paradox, we must appreciate the difficulties in estimating the age of stars. Stars like our Sun remain fairly consistent in size and temperature over extremely long periods, making it incredibly challenging to determine their age with precision. Astronomers must monitor tiny changes in a star's light and color and compare them to complex models of stellar evolution. One of the key techniques used is gyrochronology, which involves analyzing how fast a star spins. Just like a spinning top that slows down over time, stars gradually lose their rotation speed. By measuring this slowdown and comparing it to stars of known ages, scientists can use mathematical models to estimate a star's age. Methuselah is unquestionably ancient, and by current measures, it stands as the oldest star we know. But instead of fixating on whether it could be more than 2 billion years older than the universe, perhaps we should flip the trying to conceptualize 13.8 billion years is no small feat. Imagine compressing all of cosmic history into a single year, where the Big Bang happens at midnight on January 1st. Earth wouldn't appear until the last hours of December 31st, and the entire span of human civilization would fill only the final few seconds of that imaginary year. Astronomers have determined the age of the universe by studying light from incredibly distant stars formed shortly after the Big Bang and factoring in redshift, an effect caused by the stretching of light as the universe expands. This data leads to the current estimate of 13.8 billion years. But a recent proposal from the University of Ottawa suggests this might be an underestimate. The theory claims the universe could actually be around 26.7 billion years old. This bold idea was introduced by physicist Rajendra Gupta, who revisited a 1929 theory by Swiss astronomer Fritz Zwicky and paired it with more recent insights. Gupta suggests that Over enormous spans of time and distance, protons lose energy, a notion that runs counter to how we currently interpret redshift. Instead of attributing redshift solely to cosmic expansion, Gupta believes it might be a combination of factors. If true, this hybrid explanation could completely alter our understanding of how old the universe really is, potentially resolving several long-standing debates, many of which have come to light thanks to recent findings from NASA's space telescopes. Gupta's theory builds upon the tired light concept and introduces something called evolutionary interaction constants, originally suggested by theoretical physicist Paul Dirac, which proposed that the nature of cosmic forces may have changed over time. It's worth remembering that our ideas about the age of the universe have evolved significantly. Back in the 1920s, Edwin Hubble estimated the universe's age to be around 2 billion years. Over the decades, more accurate observations have adjusted that number upward to the current consensus of 13.8 billion. Whether we think of human history as a few seconds or milliseconds on a vast cosmic clock, there's no denying that the universe is incomprehensibly ancient, and its ongoing expansion constantly challenges our previous assumptions. Meanwhile, scientists are making fascinating observations about our own Milky Way. For example, recent data has shown that stars on the outer edges of our galaxy move much more slowly than stars in other galaxies. One theory is that the Milky Way contains less dark matter than we thought. Dark matter, though invisible, plays a major role in how gravity behaves on a cosmic scale. Another possibility is that our understanding of how dark matter is distributed across the universe is flawed. This mystery arises from information gathered by the European Space Agency's Gaia mission, which has charted nearly 2 billion stars in our galaxy. These findings have made astronomers rethink how stars behave, especially at the fringes of the Milky Way. The speed at which stars orbit is directly tied to the galaxy's total mass. Gravity's grip depends on how much matter, both visible and invisible, is present. A recent analysis using Gaia's data suggests that the Milky Way's mass, including stars, gas, dust, and dark matter, might be about 200,000 billion times the mass of our Sun, which is 5 times lower than earlier projections. This drastic reduction could imply a surprising lack of dark matter. Still, calculating a galaxy's mass is extremely complicated, and uncertainties in the satellite data or in the analytical models used could skew the results. As we gather more refined data and develop better instruments, we'll continue to track these developments. Looking ahead, future technological advances and space missions will likely illuminate many of these unresolved cosmic puzzles. The James Webb Space Telescope, with its unmatched power, is pushing scientific boundaries in ways never seen before. Its mission goes far beyond estimating the ages of stars or the universe itself. It's also revealing the inner workings of galaxies, the strange properties of dark matter, and the unseen forces shaping cosmic evolution.